before, we have, basically what we're doing here is we're testing you on your knowledge of exponential properties. How we add and subtract, multiply, divide them, what we do with the exponents, okay? So x to the 3/5 to the 2/3 power. What do we do when we've got two exponents that are right next to each other like this? Well, we multiply the exponents. So we have x to the 6/15, and when I simplify that, I have x to the 2/5. Okay? Here we have to add them together because here we have only one base in the exponents together. Here we have the same base. So x squared, if I have x squared times x to the 3rd, I get x to the 5th. So I need to add these exponents. I forgot to set my timer, sorry. Okay, so I need a common denominator. I'm going to make that be 21. So if I rewrite 3/7 with the common denominator of 21, it's going to be 9/21, right? Because I'm multiplying the top and the bottom by 3. So this is x to the 9/21. And then 4/3, and I make that 21 on the bottom. I multiply that by 7. I multiply the top by 7. So I have x to the 28/21. And I get x to the 37/21. Let me just double check myself. Yep, that's it. Weird, I know, but that's the answer. All right, so here, I think what I'm going to do, I'm going to make everything well, let's simplify the denominator first and see where we're at. So we've got, this is f to the 3/2 over, I'm adding these together, so I've got 3/5 or 3/4 plus 5/4 is 8/4. So this is f to the 3/2 over f squared. Now, is that what I did it differently. I did it differently on the key. But I've got this 3/2 and I can subtract 2 from here. So 3/2 minus 2, I need a common denominator, so 3/2 minus 4/2. This is going to give me f to the -1/2. All right, so I've got f to the -1/2. Well, the problem with that, if I rewrite that, that's going to be 1 over the square root of f. And I can't have that. So I multiply the top and the bottom by the square root of f, and I end up with the square root of f over f, which is the same thing as f to the 1/2 over f. That was tricky. There won't be one like that on the test. Okay? X to the -5/7. We have 1 over x to the 5/7, right? And sure would be nice if that was it, but it's not, because I have a radical. If I rewrote this, this is the same thing as the 7th power of x to the 5th. Okay, this is the same thing. So I need to get the radical out of the denominator. All right, so in order to do that, I need to multiply x by something that's going to give me a perfect 7th under here. So I'm going to multiply by x to the 2/7 on the top and the bottom. That gives me x to the 2/7, and on the bottom, it gives me x to the 7/7, right? So now I'm left with x to the 2/7 over x. And that is the answer. All right. Yes, I can move this up. Let me move this up. There are different ways. You can see part of the reason I'm holding my papers because there's different ways to find the answers and to simplify these, and I'm trying to be consistent. Okay, so this one, we have 48 to the 1/4, 3 to the 1/4. They have the same index, so I can actually just take care of this inside the parentheses the way it is. So 48 divided by 3 is 16. So I have 16 to the 1/4 squared. Well, the 4th root of 16, or 16 to the 1/4 power, is 2, and 2 squared is 4. All right. Over here, I'm going to distribute this -2 to these two, and I end up with 1/3 to the 2/3, 9 to the 2/3, right? Because it's negative, so they're going to go down here in the denominator. And since they have, wait, can I do that? Because they have the same index, I can multiply these together and I get 27 to the 2/3. And this equals 1/3 squared, which is 1/9. Okay. Solve the equation. Almost done. Well, sort of. We'll have one more video after this and then we'll be done. Okay, solve the equation. So this first one, I have a negative on both sides. So if I divide by a negative, those both become positive. And now my radical is by itself. It's not by itself with that negative right there, but now it is. So now when I square both, I get 7x minus 3 equals 25. I add 3 to both sides, 7x equals 28. Divide by 7, x is 4. Okay, over here, again, I've got to get this radical. It's not in radical form, but I've got to get that by itself. So I'm going to add 6 to both sides first. And I'm going to divide by 2. So x plus 1 to the 3/2 equals 8. Now what's going to undo 3/2 is 2/3. So I'm going to take both sides to the 2/3 power. All right, so these cancel over here. And I end up with x plus 1 equals 8 to the 2/3. 8 to the 2/3 is 2. Just kidding. It's 2. What? Yeah, I'm sorry. It's 4. So x plus 1 equals 4. Subtract 1 from both sides, and I get 3. Sorry, I was looking one step ahead on that problem, and I was like, what? Okay. Let's finish this, I hope, in the next and hopefully last video.